4 mole each of SO2 and oxygen gas are allowed to react to form SO3 in a closed vessel. At equilibrium, 25% of oxygen is used up. The total number of moles of all the gases at equilibrium is. So the reaction will be 2SO2 plus oxygen will give 2SO3. Initial number of moles are 4, 4 and 0. At equilibrium, 4 into 1 minus 0.25. Same for oxygen, and for the product it will be 0.5. So we have to add all this. The total number of moles is equal to 4 into 1 minus 0.25 plus 4 1 minus 0.25, and of SO3 is 0.25, which we multiply by 2, so we get 0.5 plus 0.5 equal to 4 minus 1 plus 4 minus 1, which is equal to 6.5. So option A is the correct answer. So the following question is, 3 moles of PCl5, 3 moles of PCl3 and 2 moles of Cl2 are taken in a closed vessel. At an equilibrium, the vessel have 1.5 moles of PCl5. The number of moles of PCl3 present in it is. So reaction is PCl5 will give PCl3 plus Cl2 at initial concentration 3, 3 and 2. At equilibrium we get 3 minus x, 3 plus x and 2 plus x. So given that 3 minus x is equal to 1.5, so x is equal to 1.5. Therefore number of moles of PCl3 gas present is 3 plus 1.5 is equal to 4.5. So option B is the correct answer. Next question is, consider the reaction where Kp is 0.497 at 500 Kelvin. PCl5 reversible of PCl3 plus Cl2. If the three gases are mixed in a rigid container so that the partial pressure of each gas is initially 1 atmosphere, which is true? A. More PCl5 will be produced. B. More PCl3 will be produced. C. Equilibrium will be established when 50% reaction is complete. D. None of the above. So from the given equation we can write Qp is equal to partial pressure of PCl3 into PCl2 divided by PCl5. So we can write it as 1 into 1 upon 1, which is equal to 1 atmosphere. Since Qp is greater than Kp, the equilibrium will shift towards the left hand side. So more PCl5 will be produced. So option A is the correct answer. So in the given question is, 3 moles of A and 4 moles of B are mixed together and allowed to come into equilibrium according to the following reaction. 3A plus 4B gives 2C plus 3D. When equilibrium is reached, there is 1 mole of C. The equilibrium extent of the reaction is. So the reaction will be 3A plus 4B will give 2C plus 3D. So K1 we can write it as C square D cube A cube B raised to 4. When C is equal to 1, we can write as 3 by 2A plus 2B will give C plus 3 by 2D. So K2 is equal to C D raised to 3 by 2 divided by A 3 by 2 B square. On comparing equation 1 and 2, this is equation 2, equation 1, we get K2 square equal to K1 square, or K2 is equal to K1 raised to half. So equilibrium extent is equal to half. So option C is the correct answer. So next question is, for the reaction N2 plus O2 gives 2NO, the equilibrium constant is K1. The equilibrium constant is K2 for the reaction 2NO plus O2 gives 2NO2. What is K for the reaction of NO2 dissociates into half N2 plus half O2? So we got equation 1 as N2 plus O2 will give 2NO K1 be the equilibrium constant for this equation, and then 2NO plus O2 will give 2NO2 K2 be the rate constant for this equation. Divide by, so we get N2 plus 2O2 on adding both the equations 2NO2 where K is equal to K1 into K2. This is the equilibrium constant. Therefore, for NO2, half N2 plus O2, let K dash be the equilibrium constant, where K dash is equals to 1 upon K1 K2 raised to half. So option D is the correct answer. So next question is, for the reaction AB will give A plus B, where AB is 33% dissociated at a total pressure of P. Therefore, P is related to Kp by one of the following options. So AB dissociates into A plus B. Initial number of mole is 100. At equilibrium it is 1 minus 0.33. So this will be 0.33 and 0.33. So PA is equal to 0.33 divided by 1.33 into P, and PB is equal to 0.33 divided by 1.33 into pressure. Therefore, PAB is equal to 0.66 divided by 1.33 into P. Therefore, Kp is equal to Pa into Pb upon PAB. Substituting the values, we get Kp is equal to 0.33 into 0.33 into P divided by 0.66 into 1.33. So P upon Kp is equal to 8. Therefore, P is equal to 8 Kp. So option D is the correct answer. Our next question is, if alpha is the fraction of Hi dissociated at equilibrium in the reaction 2Hi gives H2 plus I2, then starting with 2 moles of Hi, the total number of moles of reactants and products at equilibrium are. The reaction will be 2Hi will give H2 plus I2. At initial concentration, this be the moles. At equilibrium, 1 to 1 minus alpha, alpha and alpha. Total number of moles is equal to 2. Therefore, option B is the correct answer. The reaction 2A plus B will give 3C plus D is begin with the concentration of A and B both at initial value of 1 mole. Reached the concentration of D is measured and found to be 0.25 mole. The value for the equilibrium constant for this reaction is given by the expression. Okay, we can write the equation as 2A plus B will give 3C plus D. Initial concentration be 1100. At equilibrium we get 1 minus 0.5, 1 minus 0.5, and here 0.25, and here we get 0.75 and 0.25. Therefore, K is equal to 0.75 cube 0.25 divided by 0.5 square and 0.75. So option B is the correct answer. In which of the following reaction the value of Kp is equal to Kc? Okay, in equation 1, H2 plus I2 will give 2Hi, where number of product of moles and number of product for reactants are equal. So Kp is equal to Kc. Therefore, the value of Kp and Kc will equal for option A. In statement B, the number of moles is not equal, as it is 1, and in this it is 2, and in this equation it is minus 1. For the reaction SO2 plus half O2 will give SO3 if we write Kp equal to Kc RT raised to x, then x becomes, we know that Kp equal to Kc into RT raised to x, where x equals to delta Ng equal to 1 minus 1 plus half. So it will become minus half. So option B is the correct answer. For the reaction PCl3 plus PCl2 will give PCl5 at 250 degree. The value of Kc is 26 and the value of Kp for the same temperature will be. So we have to find the value of Kp. We know Kp is equal to Kc RT raised to delta N. So 26 into 0.081 into 523 raised to minus 1. On solving this, we get 0.61 as the answer. As the number of moles delta Ng is equal to 1 minus 2 equal to minus 1. So we get minus 1 from here. So option A is the correct answer. K for synthesis of HI is 50. K for dissociation of HI is, let Kc1 be synthesis of HI. So we get H2 plus I2 will give 2HI, which is equal to 50, and Kc2 with the dissociation 2HI will give H2 plus I2. Therefore Kc2 is equal to 1 upon Kc1, which is equal to 1 upon 50, which is equal to 0.02. So option D is the correct answer. For which of the following reaction Kp is equal to Kc? For Kp equal to Kc, delta N, that is number of moles of reactant product minus number of moles of reactants, should be equal to 0. So the coefficient in front of the product or reactant should be same, the addition of the coefficient. So in the first equation, the number of moles of product is 3 minus 2, which is equal to 1. In the second equation, number of moles of gaseous reactants and products are 2 plus 2 minus 4, which is equal to minus 2. In equation third, it is 2 minus 2 is equal to 0, and in equation 4 it is 2 minus 1 equal to 1. So in equation third, the number of moles of product minus reactant are 0. So Kp is equal to Kc. Option C is the correct answer. The equilibrium constant for the reversible reaction N2 plus 3H2 will give 2NH3 is K, and for the reaction of half N2 plus 3H2 will give ammonia. The equilibrium constant is K dash. K and K dash will be related as. So we know that K dash is equal to K raised to N. From this we know that N is equal to half. Therefore K dash is equal to K half. Therefore K dash is related to K as root of K. So option B is the correct answer. Next question is, the equilibrium constant for the reaction N2 plus 3H2 will give 2 ammonia is K. The equilibrium constant for the reaction of ammonia plus half N2 plus 3 by 2H2 is. So in this reaction, K1 for the reaction N2 plus 3H2 will give 2 moles of ammonia, and K2 is for ammonia dissociation into half nitrogen plus 3 by 2 times of H2. K1 into K2 we get 1 upon K2 as ammonia square divided by N2 into H2 cube into N2 raised to half H2 3 by 2 and ammonia. So on solving this we get half K2. Therefore we can write this as K2 is equal to 1 upon root of K1. So option B is the correct answer. Option D is the correct answer. For the gaseous phase reaction, 2NO will give N2 plus O2. Delta H is equal to 43.5 kilocalorie per mole. Which statement is correct? A. K varies with addition of NO. B. K decreases as temperature decreases. C. K increases as temperature decreases. D. K is independent of temperature. As the number of moles is equal to 0, we can write 2.303 log of K2 upon K1 is equal to delta H upon R T2 minus T1 upon T1 into T2. So as delta H is positive, delta H is equal to positive for the reaction. So K decreases as temperature decreases. If Kc is the equilibrium constant for the formation of ammonia, the dissociation constant for ammonia under the same temperature will be. Formation and dissociation of ammonia can be given as half N2 plus 3 by 2 of H2. We can write Kc is equal to N2 raised to half H2 raised to 3 by 2 divided by ammonia, or we can write as half N2 plus 3 by 2 of H2 will give ammonia. For this, Kc is equal to ammonia divided by N2 raised to half H2 raised to 3 by 2. So for dissociation, Kc is equal to 1 upon Kc dash. So option D is the correct answer. The following equilibrium given by N2 plus 3H2 will give Z N2 ammonia K1. N2 plus O2 will give 2NO. K2 is the equilibrium constant, and H2 plus half O2 will give water H2O. K3 is the equilibrium constant of the reaction. 2 ammonia 5 by 2 O2 will give 2NO plus 3H2 in terms of K1, K2 and K3 is. So we have to find the equilibrium constant for this reaction in terms of K1, K2 and K3. So we know that 2 moles of ammonia will give N2 plus 3 hydrogen. K is equal to 1 by K1, and N2 plus O2 will give 2 NO. This is K dash is equal to K2, and 3H2 plus 3 by 2 O2 will give 3 motor molecule. So K double dash is equal to K3 cube. Addition of all this reaction, we get 2 ammonia plus 5 by 2 O2, 2 NO plus 3H2O. Therefore, for the given reaction, K is equal to K dash into K and K double dash. Therefore, K is equal to 1 upon K1 into K2 into K3 raised to thrice. So we can write this as K2 into K3 raised to thrice divided by K1. So option A is the correct option. So our next question is, in a catalytic conversion of nitrogen to ammonia by Haber's process, the rate of reaction was expressed as change in concentration of ammonia per time is 14 to 10 raised to minus 3 mole per liter per second. If there is no side reaction, so option A will be 16 to 10 raised to minus 3, B 20 into 10 raised to minus 3, C 1.200 and D 10.3 into 10 raised to minus 3. So our given reaction will be nitrogen plus hydrogen will form ammonia. When we balance the equation, we get 3 hydrogen and 2 ammonia. So we can write this as minus D n by 2 and dt is equal to 1 by 3 rate of hydrogen upon dt, which is equal to half d of ammonia. dt. So we can write 3 by 2 into ammonia by dt. We know the rate of ammonia per time is 40 into 10 raised to minus 3. So 3 by 2 into 40 into 10 raised to minus 3, which give us the answer is equal to 60 into 10 raised to minus 3. So option A is the correct option. For the system 3A plus 2B gives C, the expression equilibrium constant is. For the given reaction, equilibrium constant for the reaction 3A plus 2B C is K is equal to C upon A raised to 3 B raised to 2. The coefficient must be raised to the respective product. So option D is the correct answer. Unit of equilibrium constant for the reversible reaction H2 plus I2 give 2HL is. So the unit of Kp is equal to atmosphere raised to change in N, and the unit of Kc is equal to mole per liter raised to delta N, equal to mole per liter. Change in number of moles is equal to 0, so the unit is 0. None of this. For which of the following reaction does the equilibrium constant depend on the unit of concentration? Of all the reaction, in reaction D, the number of moles is equal to total number of coefficient of product and reactant is 2 minus 1 delta N is equal to 1. So in reaction D, the number of mole for this is 1. So the equilibrium constant depend on the unit of concentration. Option D is the correct answer. In the reversible, A plus B will give C plus D. The concentration of each C and D at equilibrium was 0.8 mole per liter. Then the equilibrium constant K will be. Suppose 1 mole of A and B each taken, then 0.8 moles per liter of C and D each formed. Remaining concentration of A and B will be 1 minus 0.8 is equal to 0.2 mole per liter each. Therefore, Kc is equal to C upon D upon A into B, which is equal to 0.8 into 0.8 divided by 0.2 into 0.2, which is equal to 16. So option D is the correct answer. 4 moles of A are mixed with 4 moles of B at equilibrium. For this reaction, A plus B will give C plus D. 2 moles of C and D are formed. The equilibrium constant for the reaction will be. So we know that A plus B will give C plus D. Initial concentration is 4, 4, 0, 0. After time t, we get 4 minus 2, 4 minus 2, 2 and 2. So equilibrium constant is equal to C D A B is equal to 2 into 2, 2 into 2 is equal to 1. So option C is the correct answer. On a given condition, the equilibrium concentration of HI, H2 and I2 are 0.8, 0.1 and 0.1 mole per liter. The equilibrium constant for the reaction H2 plus I2 will give 2HI will be. So the given reaction is H2 plus I2 will give 2HI. As we know, HI is equal to 0.8, H2 is equal to 0.1 and I2 is equal to 0.1. So Kc is equal to 0.8 square upon 0.1 into 0.1. On solving we get 64. Option A. Partial pressure of A, B, C and D on the basis of gaseous system A plus 2B will give C plus 3D and A is equal to 0.2, B equal to 0.1, C equal to 0.3 and D equal to 0.5. The numerical value of equilibrium constant is. So the given reaction will be A plus 2B will give C plus 3D. K K is equal to PC, which is partial pressure of C, partial pressure of D, partial pressure of A, and partial pressure of B. So substituting the value, we get 0.3 into 0.5 into 0.5 into 0.5 divided by 0.2 into 0.1 into 0.1. On solving, we get 18.75 as a final answer. So option B is the correct answer.